Every Magento install has hundreds of modules, and somehow they all load in an order that actually works: EAV before catalog, catalog before the modules that extend it. Nobody handwrites that order. Today we open the real source behind it, how a single PHP file makes a module exist at all, how module.xml declares what has to come first, and the exact sorting algorithm Magento runs to turn a pile of declared dependencies into one deterministic load order. Welcome back to Magento Development Deep Dive. Last time we traced the boot sequence from pub/index.php down to the object manager. Today we slow down on one piece of that sequence, how Magento even knows a module exists, and how it decides what order to load them in. Everything on screen is pulled verbatim from tag 2.4.9 of Magento/Magento 2, the same commit we cited last time, so you can check every line yourself. By the end of this part, 5 things should click. What registration.php actually does at the PHP level, and why that's a different mechanism from Composer's own autoloading. How module.xml sequence block declares a hard load order dependency on other modules. How the ModuleList loader class reads every module.xml on disk and assembles them into one array. The bubble sort style algorithm Magento actually runs to turn a pile of declared sequences into one final, deterministic load order. And how a circular sequence reference module A depending on B depending back on A gets caught and thrown as an exception instead of hanging the framework in an infinite loop. 5 stages get a module from existing on disk to a fixed position in the load order. Registration.php makes the module exist as far as Magento's component registry is concerned. Module.xml, specifically its sequence block, declares which other modules have to load first. ModuleList's loader class reads every module's module.xml off disk and builds one big associative array out of them. Its expandSequence method walks each module's declared sequence recursively, so if catalog depends on EAV and EAV depends on something else, that whole chain gets flattened out. And sortBySequence takes all those expanded, flattened sequences and bubble sorts the module list into the one final order Magento actually loads in. A few things help going in. A real Magento 2.4.9 checkout, or just the GitHub tag open in a browser tab, so you can follow every file reference. It helps to have watched part 1 of this series, since we covered ComponentRegistrar, the class that registration.php actually calls into, in some depth there. Basic comfort reading PHP arrays and a simple recursive function will get you through everything today. And you don't need any Magento CLI or setup experience, this is pure source reading, start to finish. Here's the real registration.php from Magento_catalog, one of the biggest modules in the whole system, and it's exactly as small as the one we saw for Magento_store in part 1. It imports ComponentRegistrar and calls its static register method, passing the component type module the fully qualified module name, Magento_catalog, and under dir, PHP's constant for the directory this file lives in. That's the entire mechanism. There's no manifest file, no database row, no composer metadata involved in this specific step, just a static method call that runs the moment this file gets required. And here's the real module.xml for Magento_catalog, sequence block included. 4 modules are listed: EAV, CMS, Indexer, and Customer. This isn't a suggestion or a composer version constraint, it's a hard statement that catalog's own setup and configuration logic assumes these 4 modules have already been loaded and configured first. EAV heads the list for a very concrete reason: catalog's products are EAV entities, so the entity attribute value tables and attribute definitions catalog depends on have to exist before catalog's own schema and data patches try to reference them. Module.xml is in freeform, it's validated against this XSD schema, module.xsd, every time Magento parses it. The module sequence complex type says a sequence block can contain any number of module elements, and each one is required to carry a name attribute matching the module name type, which the schema separately restricts to a specific pattern: capital letter, then letters or digits, an underscore, then another capital letter, then more letters or digits. Get the casing wrong, or forget the underscore that separates vendor from module name, and Magento's XML parser rejects the file outright, before your sequence logic ever gets a chance to run. This is what registration.php actually calls into. Register first validates the component type as one Magento recognizes: module, library, theme, language, or setup. Then it checks whether that exact component name is already registered for that type, and if it is, it throws a logic exception naming both the new path and the path it collides with. That's the real error message you get when 2 modules accidentally share a name. Only if there's no collision does it write the path into a static array, normalizing backslashes to forward slashes along the way. Static means this array lives for the whole PHP process. Every subsequent step we cover today reads back out of exactly this array. This is ModuleList's loader class, and load is where every registered module's individual module.xml file actually gets read and parsed. Get module configs, a private generator we don't have room to show in full, calls back into ComponentRegistrar's get paths to enumerate every registered module path, then yields each one's module.xml contents in turn. Each file gets parsed into a DOM, converted into a plain associative array keyed by module name, and folded into one big result array unless that module name was explicitly excluded. And notice the very last line, load doesn't return that raw result directly. It hands it to sortBySequence first. expandSequence is the method that turns a module's direct sequence declaration into its full, transitive set of dependencies. It's recursive. For each module in the current module sequence, it calls itself again to expand that module's own sequence, and merges everything together. The accumulated array is the cycle guard. Every module name gets added to it as the recursion descends, and if expandSequence is ever asked to expand a name that's already in that array on the current call stack, it throws a logic exception naming both the parent and the offending module, instead of recursing forever. That's the exact mechanism that turns a circular module.xml sequence into a clear startup error instead of a hung process. With every module's full transitive sequence expanded, sortBySequence runs what the source code's own comment calls bubble sorting, deliberately, because a standard usort doesn't guarantee every pair gets compared, and here that guarantee actually matters. For each pair of modules I and j, if module j appears in module i's expanded sequence set, meaning j has to load before I the two get swapped. Run that comparison across every pair, and the modules that nothing depends on sort to the front, with everything else falling in behind whatever it declared a dependency on. This is the literal function call that decides whether EAV's setup runs before or after catalogs on every single Magento request. One thing worth being precise about, module.xml sequence has nothing to do with whether a module is enabled or disabled. That's a separate concern, handled by the Manager class here, and its isEnabled method is a single line. It asks the ModuleList interface whether the module is in its list at all. Under the hood, ModuleList checks the enabled modules recorded in app/etc/config.php, the filebin /magento module :enable and module :disable actually write to. A disabled module's registration.php still runs, and it still gets sorted into the sequence graph. It just gets filtered out of the final enabled list before anything ever tries to instantiate its classes. A few things trip people up here. Sequence controls load order, not whether Magento refuses to start. If a module lists a sequence dependency on a module that isn't installed at all, Magento doesn't necessarily fail hard, it just sorts around what actually exists. A duplicate component registrar register call for a name that's already taken throws immediately, at the moment that second registration.php gets required, which is exactly why copy-pasting a module without renaming it breaks the whole install instantly. A circular sequence reference throws a logic exception that names both the parent and the module it's cycled back to. Read that message literally, it's telling you the two files to go open. And disabling a module through config.php never removes it from the sequence graph loader builds, it only removes it from the enabled list manager in ModuleList check against. Let's pull this together. Registration.php calling ComponentRegistrar : register is what makes a module exist at all, stored in a static, in-process array. Module.xml sequence block is where a module declares hard load order dependencies on other modules, and that XML is validated against module.xsd before Magento ever trusts it. Loader's load method reads every registered module's module.xml off disk and folds it into one big array. expandSequence walks each module sequence recursively, flattening transitive dependencies and throwing a logic exception the moment it detects a cycle. And sortBySequence, deliberately not used bubble sort, is the exact algorithm that turns all of those expanded sequences into the one final, deterministic order Magento loads modules in every single time. That's the real module system, from registration.php down to the bubble sort that decides final load order, every file and line cited from the pin 2.4.9 source. Part 3 goes into dependency injection itself. D.xml, the object manager we first met in Part 1, and how Magento resolves preferences between interfaces and concrete classes. If you want the rest of this series as it publishes, subscribe now. Thanks for watching, and I'll see you in Part 3.